So LeetCode 1673, find the most competitive subsequence. You're given an integer array nums and a positive integer k, and you need to return the most competitive subsequence of nums with a size of k. And a subsequence is just a sequence of elements in nums without reordering the elements. So you can remove some elements from the array, but you cannot reorder them, okay? And a subsequence is more competitive than another subsequence if in the first position where they differ, which could be also the first position potentially, the first subsequence has a number that is less than the number in that position in the second subsequence. So you can think of it like kind of like a lexicographic sort, okay? And then you take the first element. So let's take this example here. This is the nums array, and you need to find the subsequence with length 2. That is the first one in the lexicographic sort of all of the possible subsequences with length 2. Okay, so these are all of them. This one is the result. And why isn't it not this one? Because in the first position, this one has a number that is less than this one. Okay? All right, so the way we're going to implement and solve this problem is we're going to have a stack that we always strive to keep at a length of k. Okay, so whenever it goes under a length of k, we want to push more elements into the stack. And if it goes above, then we want to pop some elements. Okay, so the true thing is you want to always pop elements from the end of your stack if your current element that you're visiting is less than the last element in the stack. And the only other thing that you need to care about is that you do not want to starve. You do not want to remove elements from the stack if removing them will cause your stack to not reach a length of k by the time you reach the end of the nums array. So for example, let's say that k is 5 here, or actually 4 because we only have 4 elements. So k is 4. So your stack is 3, then it becomes 5. Then you get to 2, and 2 is less than 5, and it's also less than 3. So you would like this to be the first element of your subsequence. But unfortunately, since k is 4, removing these 2 elements would cause you to have a subsequence with length 2, and 2 is less than 4, so you cannot do that. So as long as you keep in mind these 2 simple rules, you should be okay with this problem. So first rule, remove elements when the current one is less than the last one in the stack. And don't forget this one, you only remove elements from the stack if removing them doesn't cause your stack to be smaller than k by the time you reach the end of the nums array. Okay? Right, so let's jump into the implementation now. So we're gonna have our stack, and we're gonna loop through all of the nums in the array. Okay? And then here are the 2 rules that we were talking about. So if and while, actually, while the current number is less than the last number in the stack, and don't forget this one, and we can remove from the stack, then we can pop the last element in the stack. Okay? And we're going to implement this later on. Okay? And now, after popping all of the numbers from the stack that are greater than us, then what we do is we check if the stack length is less than k. And if so, it means that we have popped some elements, and so we need to fill the stack back up. And so we push the current element into the stack. Okay, so now all that's left is to just return the stack, because we are guaranteed that our stack is of length k, because we only push to the stack if the length is less than k. So the stack length never goes above k, so we don't have to slice or do anything like that. Okay, and now one more thing is to implement the can remove from stack at position I. So again, this function, what this function needs to do is it needs to check if you can remove one element from the stack, considering that you are at position I in the nums array. So for example, if we are in the last position of the array and our stack length is currently like 3 and k is 4, then we cannot remove an element from the stack, because otherwise our stack would end up having a length of 3, which is less than 4, which is k. And so we cannot do that. So yeah, we just need to do that. So this is the amount of elements left in the array that you haven't visited yet. Okay, and this is the amount of positions that you need to fill in the stack. And so if the amount of positions that you need to fill in the stack is less than the numbers that you have left in your nums array, then it's okay. You can remove elements because you're going to have enough anyway. But if it is equal, then you cannot, right? You cannot remove, because if you remove from your stack, you won't have enough elements left in the nums array to fill it back up to a length of k. So yeah, that's it. I'll submit the solution to show you that it works. And the time complexity is O of n, because you just go through all of the numbers once. And the space complexity is O of k, because the most that you store in the stack is length of k. And again, that's why we can just return stack without slicing or things like that. So that's it for me today. Thank you for watching, and bye.